Okay, before we get into some examples, let's talk a little bit more about notation. I think while this might be a conceptually simple unit where we're just talking about right now adding, subtracting numbers, and listing out numbers in a sequence, the notation is unfortunately what trips us up a lot. So let's kind of talk about that for a second here. In general, the general term or nth term we call it of a sequence is represented by some symbol with a subscript, for example, u sub n, t sub n, or t sub n, or a sub n. And we would say that the general term, this general a sub n or u sub n, is defined for n equals 1, 2, 3, 4, and so on and so forth. The reason why we use n is because n is the natural number. And the natural number is just like the whole numbers, 1, 2, 3, 4, 5, 6. They're the counting numbers. So when we talk about these sequences, you can have a first term, you can have a second term, you can have a third term, but you can't have like a 2.5th term. And so that's why we're talking about these sequences with these subscripts. U sub 1 would be the first term, U sub 2 would be the second term, and so on and so forth. This set notation, the set U sub n, represents the sequence that can be generated using some general U sub n term as the nth term. We'll see this notation pop up here and there. So for an example, the notation, the set U or 2n plus 1 would generate the sequence 3, 5, 7, 9, 11. And if you're wondering, like, well, where do these numbers come from? That's by plugging in these natural numbers in for n. So when I plug in a 1 for n, I get 3. When I plug in a 2 for n, I get 5. When I plug in a 3 for n, I get 7, and so on and so forth. So these sets always will use these numbers, 1, 2, 3, and so on and so forth. You can't start at 3. Our sequences always begin with the first number. All right, so in general too, I think it's a good idea to just kind of make this association of n, the counting numbers, and u sub n. In algebraic terms, we'd say n could equal 1, 2, 3, 4, and so on and so forth. And our algebraic notation would be for the first term in a sequence, we would have the term u sub n. For the second term in a sequence, we'd have the term u sub 2. For the third term in the sequence, we'd have u sub 3. Fourth term would be u sub 4. And if I were to take this out to the nth term, this would be u sub n would be whatever the term is in the sequence. So I guess we could say this is like the term, and then this is like the when it happens. The first, second, third, fourth, and this is like the what. Here's the n is the when, the u sub n is the what. So let's talk about numbers. We always are going to use these natural counting numbers for our sequence, and I could count by odd numbers starting at 7. So 7 could be my first term, 9 could be my second, 11 could be my third, and 13 could be my fourth. This is just some random occurrence or random sequence that I've come up with, but there is a first term which is associated with 7, a second term which is associated with 9, a third term which is associated with 11, and a fourth term which is associated with 13. So we're throwing all this language around, and hopefully it'll start to stick as we see some more examples. So let's use this notation. Here I have some sequence defined by u sub n is going to, in general, u sub n is going to be given by 3 times n minus 2. So let's find u sub 1. So to do that, that means that I'm finding the first term in this sequence. So that means that n is going to equal 1. So that means that I'm going to multiply 3 times n and subtract 2. So u sub 1 is going to equal 3 minus 2, which is equal to 1. That means the first term in the sequence is 1. This is a rule that comes up with a sequence of numbers. The first number in that sequence is 1. For letter B here, we want to find u sub 5. This is a way of saying it's the fifth term in the sequence. So that means that I'm going to use the natural number or the counting number 5, meaning that I want the fifth term in the sequence, minus 2. So this will be 15 minus 2. So the fifth term in the sequence is 13. And then finally, let's go for letter C. I want the 27th term. And that's going to be given as 3 times 27 minus 2. This would be the 27th term, so I'm putting in 27 for the number n. And so u sub 27 is going to equal, let's see, that's 81. Oh, I guess I should have known that. That's 81 minus 2. So u sub 27, the 27th term in the sequence is 79. All right, so why don't you try an example like this? We have a sequence defined by, this is now a little bit different because we have an exponential here, but we can still figure it out using the same strategy. I want you to find u sub 1, u sub 5, and u sub 8. So pause the video and resume when you're ready to check your answer. All right, and the answers here, I guess I didn't write these out. So let's just do this together. So u sub 1 is going to be 2 to the 1 minus 1 minus 10. So u sub 1 is going to equal, this would be 1 minus 10, so this is going to be negative 9. That is u sub 1. For b, u sub 5 is going to be 2 to the 5 minus 1, all that minus 10. So u sub 5 is going to be, this is 2 to the 4th. So let's say 2 to the 4th is 16 minus 10 is 6. And then for c, u sub 8, the 8th term in this sequence is going to be 2 to the 8 minus 1 minus 10. So that means, let's see, 2 to the 7th, 2 to the 5th is 32, so 6 would be 64, 2 to the 7th would be 128, 128 minus 10 is 118, and so u sub 8 is 118. So hopefully you were able to get there. Let's take a pause here, and then we'll do some more examples in the next video.